We're only going to do one of these. This time we are given that cosine of theta is equal to negative 3 over 7. And cosecant theta is greater than or equal to 0. We did these last unit, so the start is very similar to how we did it before. First, the cosine of theta equals negative 3 over 7. That tells us some pretty important information. Cosine is what over what? A over h. And remember, h is always positive, so obviously I put the negative with the 3, but if it weren't specifically put with the 3, it would have to be. H cannot be negative 7. So we know from this piece that a is negative 3 and h is positive 7. We know that much. The other piece we can get is from a combination of cosine being negative and then the sign on cosecant. So we already know that cosine of theta is negative. That's given. And then we know that cosecant of theta is greater than or equal to 0, so it's positive. That also tells us that what else is positive. If cosecant is positive, what else is positive?
Sine.
Sine. Thank you. Now putting both pieces of information together. Positive sine, negative cosine. Which quadrant are we in? Second quadrant. We remember all students take calculus. Sine is positive in the second quadrant. That's how we know that. This information is what we need in order to make a graph. We know we're in quadrant 2, so we'll start there. Draw in your angle of rotation and label it with a theta. Draw and label alpha. Alpha goes from the x-axis up to the angle. And now we can finish off the triangle. I'll go ahead and label HOA. Hypotenuse, O is always on the vertical, A is always on the horizontal. We were given that A is negative 3 and the H is 7. We need to find O still because we're going to be filling out the trig functions in just a moment. It's a right triangle. How do we find a missing side? Pythagorean theorem. A squared plus B squared equals C squared. I'm going to let little a be our adjacent. So we have negative 3 squared. Plus, I'm going to fill in O for the B. O squared equals, and then our c squared is our hypotenuse squared, equals 7 squared. That's going to give us positive 9 plus o squared. And I'm going to give o a little curl so we don't think he's a 0. Equals 49. Subtract the 9 over. O squared is 40. Then we square root both sides. O is equal to plus or minus the square root of 40. I know it's been a minute since we've done one of these, but when it does come up, we need to make sure we do this properly. If you have a non-perfect square that can still be simplified, we're going to do that. So we can break down this radical. I'm going to do it the way I teach it in Algebra 2. That may differ from how you learned it or how you prefer to do it. So if you prefer to do it a different way, then you do it your way. I'm going to show you my way. To make it very simple, I tell my students to just pick 2 factors of 40, the first 2 that come into their head, whether or not that contains a perfect square, just depends. This case for me, it'd be 4 and 10, which does contain a perfect square. So I'm going to break this down into square root 4 and square root 10. And then I'll break the 4 down into 2 and 2 to make the pair. 10 we can break down into 2 and 5, but that doesn't get me anywhere because I can't make another pair. So this becomes 2 times the square root of 2 times the square root of 5. So I'm going to bring this down. O equals plus or minus. This is 2 square root of 10 to simplify it. Now, is O going to be positive or negative in this problem? It's going to be positive. If we look at the quadrant we're in, O, the vertical, is above the x-axis. It's parallel to the positive side of the y-axis. So, O is positive here. You do need to ask yourself, because depending on the quadrant, that's going to change your answer. So O is positive here. And again, that's because we're in quadrant 2. So now that I've finally found O, I can fill him in on my triangle. 2 square root 10. Now we can fill in all 6 trig functions plus theta and alpha. We have sine of theta, cosine of theta, tangent of theta, the reciprocals, cosecant theta, secant theta, cotangent theta, and lastly theta and alpha. Let's start with the trig functions. Sine O over H, that's 2 rad 10 over 7. Nothing to change there. Cosine A over H, that's negative 3 over 7. Tangent O over A, that's 2 rad 10 over negative 3. And the reciprocals, cosecant, that's 7 over 2 rad 10. And as always, we have to rationalize that denominator. So we're going to times square root 10 over itself. On the top, that's going to give us 7 square root 10. On the bottom, that's just going to become 2 times 10, so 20. Secant, yes?
Wouldn't that be 14 square root of 10?
Where'd you get 14?
Because they have to multiply the 2 square root of 10 by itself on top and on bottom, or you just multiply it by.
Yeah, I just did the square root of 10 because if you do, you can do 2 square root of 10 top and bottom, but then you're going to have to reduce. Because did you end up with 14 over 4? Yeah, so it'll reduce to my answer. Secant is just going to be a nice 7/3, negative 7/3. Cotangent, negative 3 over 2 square root 10. Again, rationalize the denominator, multiply by square root 10 over itself. And we get negative 3 square root of 10 over 20. Lastly, we find theta and alpha. So a reminder, everything up to this point, aside from bringing back in Pythagorean theorem, you knew prior to this unit. This is the only new part of this unit, which is solving for alpha using the calculator. So alpha, we have to pick one of our 3 original functions. You can pick any of them. It's always preferred that you pick the positive function because alpha must be positive, so you don't have to remember to drop the negative in the process. You're welcome to pick a negative trig function and just drop the negative sign. That's completely a personal choice. I'm just going to make it easy and pick the sign since it's positive. So to find alpha, we are going to use inverse sine of 2 square root 10 over 7.
How do you know to use that one? Is it just always that one?
So I always pick the positive trig function just because that's the easiest, it's the path of least resistance since alpha must be positive. You can pick any of the 3, just make sure when you type it in you drop the negative if it has a negative on it. So I'm going to type exactly that into my calculator. Inverse sine 2 square root of 10 over 7. And reminder, we give these answers in degrees, minutes, seconds. So I'll go ahead and attach the converter at the end of that. That's under second apps, 4th option down to get the DMS. If you remember to put it at the end of your calculation, it'll save you a step. We round to the minute, 64 degrees, 37 minutes, 23 seconds. So this will not round up. 64 degrees, 37 minutes. To find theta, you have to go by the rule of whatever quadrant you're in. And again, it helps to notice that on the left side of the x-axis here, we have 180 degrees. As you can see together, theta and alpha make 180. So if I do 180 and take away the alpha, I'll get the theta. So for this quadrant, the rule, theta equals 180 minus alpha. I'll just do that in my calculator. And then don't forget to attach the DMS converter because your calculator will always give you a decimal if you don't specify. 115 degrees, 23 minutes. And there you have it.